So hi, we'll start in like 2-3 more minutes. We'll start after 2-3 more minutes so that few others can join also in the session. Okay, so I guess no one else is joining, so that I guess we can start the session. Uh, just let me turn my video. So hello, hello, welcome to like the week 3, basically the session 3 of the discrete maths problem solving session. I am Lakshya Saggi and I am the problem solving sessions TA for NPTEL for the Tuesday sessions. So this week, in this session, we'll try to solve the problem related to relations. So basically sets and relations. And like this is also a very important tool in discrete maths, although the problems may seem quite simple, but believe me, like sets and like the equivalence classes especially are a very important aspect of discrete maths or in any theoretical aspect or even in a whole lot of computer science, like basically equivalence relations and equivalence classes have a lot of importance. So the concept should be like always be clear for these sort of things. That's why like a whole problem solving session is dedicated to these types of problems related to like the types of relations and the properties of relations. So uh, let's start with the today's session. So I'll just introduce the today's session's plans. So I guess today's session won't be very long because we just have like 10 problems related to like sets and relations. And after that, like if time permits, most probably it will permit, I'll just revisit some of the problems of the previous session also, which I believe I did not explain quite clearly. So I'll just revisit those problems again so that you can understand the solution better. Right. So just let me share my screen. We'll start with the today's problems. So yeah, just let me share my screen now. So that is my screen visible? Uh, you can let me know via message in chat or via thumbs up if my screen is visible. Okay, cool. It's visible. Nice. So let's start with the problems now. So just a second. So the first problem is basically saying, so yeah, first problem is basically you must have you must have seen the lectures of this week. So in those lectures, like there's a matrix representation of relations, right? So matrix representation basically means that the I comma jth entry of a matrix, the ith row and jth columns entry of a matrix basically denotes. I'll just write it down also, I guess. Uh, Matrix representation relation over a set S. So a relation is always defined over like a set S cross S. So I just write as over a set S. So matrix representation basically says that uh, I comma jth entry of matrix. Just revising the basic theory. I comma jth entry of matrix is one if ith comma jth basically ith comma jth elements of S are related. Right. So basically, if I label the elements of S as such that A1, A2 up to like some, let's say AN. So basically AI comma AJ are related. That's basically the matrix representation. If they are not related, then I comma JF is zero. Right. Okay. So a lot of other guys have also joined the meeting. That's nice. So just to reiterate, guys, to those who have just come recently, uh, basically, this week we'll be discussing the problems related to relations and sets. And as I said earlier, also, you may find these problems trivial, but believe me that basically the relations and the equivalence relations, especially equivalence classes and equivalence relations, are a very essential part of like all of computer science. So maybe these things seem trivial, but I would definitely recommend you guys to pay attention to this sort of stuff. Yeah. So so basically, the first question is related to matrix representation. So it just asks which of the following matrices represent a reflexive relation. So matrix representation of a relation over a set S is denoted by basically I comma jth entry of the matrix is one if and only if the AI and AJth elements, basically AI comma AJ is part of the relation. If I jth elements are related, or maybe I can say belong to the relation R. So this is the definition for the matrix representation. So basically, if so a reflex, basically we need to find matrices which represent a reflexive relation. So in reflexive relations, again, just revising the definitions so that all everyone is on board. What's happening? The reflexive relation basically says that A comma A belongs to R for all A in S. I guess these notations and everything is clear to everyone. So basically in reflexive relation, like A comma A should always belong to the relation R. So this basically means that here I said that ith comma jth I comma j ai comma aj should belong to the relation R. So here basically this implies that ai comma ai should belong to relation R for all AI in X. I guess this makes sense. So basically for all elements AI, which are a part of S, AI comma AI should belong to the relation R. Only then we can say that the relation is reflexive. So for this, I think it's straightforward to see that the AI comma AIth entry will denote the ith row and ith column. So this means that ith row comma ith column basically entry at ith row comma ith column should be 1, which basically would mean that AI comma AI is related. Entry at is equals to 1. Like all of these statements are the same thing. Right, guys? So this just means that all diagonal entries should be 1. Only then we can say that the relation is reflexive, right? So here, yeah, some people are writing the answers in chat. So let's just see in what matrices the diagonal entries, all the diagonal entries should be 1, are 1. So basically in the first option, we can see that the second row comma second column is 0. So the first option is like A option is not a reflexive relation. Similarly, in B option, we can see that first entry is 1, along the second diagonal entry is 1, third diagonal entry is 1, fourth is 1, but fifth is 0. So maybe I'll just type this out also. Option A. Not reflexive because second entry along diagonal is 0. Similarly, option B. Option B is also not reflexive. And why is it not reflexive? Not reflexive here because fifth entry, the last entry, is the right fifth entry. The fifth entry along diagonal is 0. In option C, all entries are 0. So option C is a diagonal matrix. Option C, diagonal. Basically are reflexive because all diagonal entries are 1. Similarly, option D. In option D also we can see all the diagonal entries are 1. So it is also reflexive. And in option E, we can just see like there are 2 entries on along diagonal, both are 1. So option E is also reflexive. So correct answer is C, comma D, comma E. Easy to see that only these 3 are reflexive. So I'll just underline the correct answer. So yeah, we have the correct answer. So many people had written like C, D, E. So yeah, that's correct. Aditya and Solar, you both had answered correctly. So I hope it's clear to everyone. And yeah, so just to add on to this question, like I always like to ask a question and then like twist it in some manner so that maybe we can solve some variants of these questions also. So let us suppose the question was instead asking like which of the following represent a reflexive relation. Instead of it, the question was asking which of the following represents a symmetric relation. So does everyone remember symmetric? I'll just write down the definition of symmetric relation also so that everyone is on board with the definition at least. So symmetric relation means that A comma B in R if and only if B comma A in R. So basically it means that for something to be symmetric relation, A comma B and B comma A both should be related to each other. Both should be part of the relation. So suppose if the question had asked If question asks for symmetric relation matrices, basically this thing should hold that A comma B and B comma A both should be in R. Which, if I translate it into AI comma AJ manner, I'll just copy this and write it down here again. So AI comma AJ basically it says that if AI comma AJ in R, then AJ comma AI should also be in R. Then AJ comma AI also in R. This hi Surya, you can I believe you are already in, uh okay, so someone is saying that please send the meeting link. I guess you guys are, if you are attending the meeting, you guys are already in the meeting. So maybe I'll just type down the chat. Yeah, okay. I hope this issue is resolved. Okay. So logistics issues are straightforward. You can resolve it from NPTEL. I'll just get down to this problem solving. So yeah. So basically this means that if AI comma AJ in R, then AJ comma AI should also be in R. So this just means in terms of matrices, this just means that the matrix should be a symmetric matrix. So what are symmetric matrices? I believe we have studied this in high school also. So basically, symmetric matrices M, a symmetric matrix M is such that M is equals to the transpose of M. Symmetric matrix M such that is a matrix, symmetric matrix M is a matrix such that M is equals to M transpose. And transpose, I believe, what is the transpose of a matrix? We guys already know from high school that basically we just take the mirror image of the matrix along the primary diagonal. So let us see, suppose the question had asked instead of asking for which of the following relations are reflexive, it just asks which of the following are symmetric. Then how can we check? We just have to check which of the following matrices are symmetric. Basically, we have to check that the matrix and its transpose should be equal to each other. If that's the case, then then the matrix will represent a uh, symmetric relation. So yeah. So let's get down to this. So first option A, we can just do it straightforward. I'll not write here for every option. I'll just straightforward do it orally. You guys can follow easily, I guess. So first option A, we can see that these two entries, the first row and the second column and the second row's first column, one entry is 1 and the other is 0. So transpose won't be equal for the option A. Similarly for option B, we can see, I hope my cursor is visible to you guys. So in option B, we can see this entry, basically the third row and the fifth column entry is 1 here. But the fifth row and third column entry for option B is 0. So this matrix is also not symmetric. So yeah, another thing to note that basically the symmetric matrix terms derives from the symmetric relation only. Like you can see the symmetric, if a relation is symmetric, then its corresponding matrix will also be symmetric. So just a side note that basically that's how the symmetric matrix term came to be. This is from basically relations only, symmetric relations. So yeah. So option C, we can see that in option C, again, the first row, second column and second row, first column entries are not equal to each other. So this is the transpose is not equal to the original matrix. So now let's come to the option D. So in option D also we can see that this one, basically the fifth row and the second column has 1, but the second row and fifth column has 0. So this is not a symmetric matrix. And in option E, we can see that actually all entries are 1. So like transpose will also have all entries as 1. So option E is a symmetric matrix. So basically we can say that only option E is symmetric here. So yeah, I would say straightforward. So let us also assume like even if we just side note that even if we had the entry 0 along the primary diagonal in option E. So basically instead the matrix was suppose that 0, 1 and 1, 0. Then also the matrix would have been symmetric. In that case, the matrix would not have been reflexive since the diagonal entry should be 1 in reflexive, but it would still be symmetric matrix as the transpose of a matrix is equal to the matrix itself. So, but option E right now is basically both reflexive as well as symmetric. But suppose if the diagonal entries were instead 0 for option E, then it would have been uh, still symmetric but not reflexive. So yeah, just adding a side note so you guys can see that uh, this makes sense. So yeah, so first question is done. So let's come to the second question then. Second question basically asks. So yes, Aditya, you said that option E would be symmetric. So yeah, you are correct. Nice tip. So now the second question is which of we are given a set A, which is basically names of 3 people, Srijit, Akash, and Rupesh. Similarly, a set B, which is Shraddha and Sanchita. Let's just say there are 2 sets. So which of the following subsets belong to A cross B? So A cross B, we already, you guys must have seen in lectures, like what does A cross B actually mean? So A cross B is just Cartesian product of sets. Cartesian product of sets. So I'll just list out the A cross B, what its value will be here, like what will be A cross B here, so that you guys can actually visualize. I think you guys must have already seen in lectures what is A cross B, but let me just write down all the elements of A cross B so everyone is comfortable with uh, how to list out and what does it actually mean to be in A cross B. So basically in A cross B, basically uh, the A cross B set would be basically we take every element of set A and pair it up with every possible element of set B and take a collection of all of these. So basically there are 3 elements in set A and 2 in set B. So basically there will be basically 3 times 2, basically 6 elements in the set A cross B, as we can pair up any of these 3, any of the 3 elements of set A with any of the 2 elements of set B. So just let me just list out these so you guys have a better understanding and you guys can visualize basically what do these mean. So A cross B will be basically I can pair up Srijit with Shraddha as well as Sanchita. So first option, I can just say that I paired up Srijit with Shraddha. Similarly, in second option, I paired up Srijit with Sanchita. So these are the 2 possible pairings for Srijit, not anymore. So similarly, the third possible pairing will be for Akash. So Akash can be paired up with again Shraddha, and again Akash can be paired up with Sanchita. I hope everyone is able to follow this. It's not anything too complicated or something. I'm just writing it down so everyone can basically agree with the dependency with an example. What is the definition? So, yeah, and Rupesh can be paired up with Shraddha, and similarly, Rupesh can be paired up with Sanchita. So these would be the basically the set A cross B. So just for sanity check, let's check the number of elements. It should come out to be 6. Basically, 3 into 2. There should be 6 possible pairings. So 1 pairing, 2 pairing, 3 pairing, 4, 5, 6. So yeah, we have 6 pairings. So it makes our Cartesian product is this A cross B only. So now let's just try to see. Also, just note that, guys, this set A cross B is basically Cartesian product of sets, and these are basically ordered pairs. Basically, Srijit, Shraddha is will be different from, let's say, another element, if there is any, which is Shraddha, Srijit. So basically, you A cross B also invokes an ordering. So A comma B, an element A comma B will not be equal to an element B comma A. So we'll have to respect the ordering also. Okay. So I hope it's clear what I mean by that. Basically, in every element, basically Srijit will I'll have to write Srijit as first and Shraddha as second. Similarly, like Srijit as first, Sanchita as second. So if there is another element which says, like, suppose Sanchita comma Srijit, then that element will be different from Srijit comma Sanchita. So that element I'll have to add another new element for that. So we have to respect the orderings in Cartesian products. That's all I'm saying. So let's just check option A whether this whether this is a subset of the set A cross B. So Srijit comma, so basically all we have to check for being a subset is all the elements of this set should belong to the primary, like, bigger set, which is A cross B, right? So option A, Srijit comma Sanchita, I see here. Srijit comma Sanchita is here also. So Srijit comma Sanchita is there in set A cross B. Similarly, Rupesh comma Shraddha is there in A cross B. Uh, Rupesh comma Shraddha is there in A cross B. Similarly, Akash comma Sanchita is here. And Srijit comma Shraddha is here. So yeah, so all elements of option A are in the set A cross B. So yeah, as some of you guys have written in the chat also that option A. So Lat and Aditya, you guys have answered correctly. So option A, yes, basically option A belongs to A cross B. So yeah, let's just check for options, other options also. The other options are there or not? So maybe let's just check. So in option B, Rupesh comma Shraddha, and Rupesh comma Shraddha is here also. Akash comma Shraddha is in A cross B also. Sanchita comma Srijit. So Sanchita comma, as I said, you have to respect the ordering. I see a Srijit comma Sanchita here. But as I said that in basically you have to respect the orderings also. So Sanchita comma Srijit is actually different from Srijit comma Sanchita. So since we, for the set to be a subset, we required Sanchita comma Srijit to be in the set A cross B, which is not the case here. So this element is, the Sanchita comma Srijit element is not in A cross B, and because of this, option B is not a subset. So does not belong. And I'll just list out the reason. So as Sanchita comma Srijit is not in A cross B. Yeah, I hope it's clear to you guys. So option C, we'll just see for other options also, so that we have a bit more practice about this. So Akash comma Akash. So in option C, the first option only, the Akash comma Akash. I don't see any Akash comma Akash here. It's just Akash one is Akash Shraddha, one is Akash Sanchita, no Akash comma Akash. So option C does not belong, as Akash comma Akash is not in A cross B. Similarly, let's come to option D. So option D is Srijit comma Shraddha. So I guess I have used different spelling for Srijit somewhere, like here it is SRI and here it is SHRI. So maybe we can ignore that for now. That these are the same spellings. These are not two different Srijits. They are the same Srijits. So yeah. So Srijit comma Shraddha is here also. Shraddha comma Shraddha is not in A cross B. So Shraddha comma Shraddha, or like let's say Srijit comma Srijit would be like Shraddha comma Shraddha would be in B cross B. The elements of B cross B would contain Shraddha with Shraddha and Shraddha with Sanchita, and Sanchita with Sanchita and Sanchita with Shraddha. So Shraddha comma Shraddha would be in B cross B, but it is not in A cross B. So like That was I just saying so that you guys can see like where Shraddha actually can come. But here it does not like for this option, like for this question, it's just okay to know that Shraddha is. Let's copy it from here. Okay, this. But yeah, just for like for extra knowledge, or you can say for some like for some future reference, maybe like Shraddha can belong to, let's say I said B cross B. Right. So yeah. Fancy here. So let's come to the next question, guys. So next question basically asks us, what is the total number of reflexive relations of the set 5, 7, 13, 5? So first of all, uh, basically size of set S is basically the cardinality of S is here 4. Basically, there are 4 elements here inside. And okay, you guys must have seen. Okay, so that I'll just come to your answer. I'll just come to the question which you have put in the chat, like the answer, which is wrong, I would just say. So 5 is not the correct answer here. Uh, I'll just say, guys, that you guys must have, I don't know, maybe studied in the lectures the formula for computing the number of reflexive relations. So instead of the formula, I'll just write down basically how you can find. Basically, let's start from scratch. How you can find the answer. So yeah, Aditya has written the answer to the part 12, which seems correct, which I think is correct. Yes, it is correct. But let's just do it so that everyone can understand basically. Aditya, your answer is correct, but still I'll discuss it so that everyone can understand why it is the case. So basically the number of reflexive relations of the set this. So basically we need to find all possible relations over S cross S. Basically, since a basically a relation defined over a set means that we take S cross S, which we basically take the Cartesian product of S with S, and from that set we take the a subset, and basically every subset will correspond to one relation. This is the basic definition of a relation, which you guys must have done in the lectures also. So I'm just reiterating that definition, that the relation over a set is just defined as a subset of, maybe I'll just write it down here again. Relation over a set S is defined as a subset of S cross S, as basically any subset. Okay, so any subset is a relation. Any subset of S cross S is a relation over S, and we need to find the. So basically, this means that maybe I'll just come to this. So the number of elements in S cross S, how many of number of elements will be in S cross S? It's easy, guys. So this would just be basically uh, here size of set S is 4. So in S cross S, there will be like a 4 square number, since every possible element of S can be every possible element of S can be paired up with all of the 4 possible elements, right? So there would be like there are 4 elements, and these can be paired with all the 4 elements of S. So there will be 4 square possible. So 4 square possible pairings. Yeah. So basically size of S cross S is 16. So what this means is that number of possible subsets of S cross S. So basically, we need to find the number of possible subsets of S cross S. And this is just basically, this can just be written as number of elements in power set of S cross S. So this is, I guess, straightforward step, since power set is nothing but the collection of all the possible subsets of, like, let's say a set X. So basically for set S cross S, if we need to find number of possible subsets, these are just the number of elements in power set of S cross S. So you can just directly see also number of possible subsets of S cross S would be basically, I'll just take maybe I'll just define this as, okay, let's leave it with that. So maybe to find the number of possible subsets of this set S cross S, what we can do is we can take like any possible element of this S cross S, and we have two choices whether to include it or not include it. So number of possible subsets would be basically, so there are two choices, and since there are total 16 elements, so it would be 2 to the power 16, right? Yeah, just this. One second, guys. So yeah. So number of possible elements will be 2 to the power 16. Yes. So I hope this is clear to everyone. Since S cross S has 16 elements, so number of possible subsets will be 2 to the power 16. So this basically means that number of possible relations is equals to 2 to the power 16. Right? I have not done anything fancy here. So but here you can see that the total number of possible relations are 2 to the power 16. But suppose we want, but here what we want is the total number of reflexive relations, right? So earlier, how did we arrive at this number, 2 to the power 16 number? Okay, so you are saying that phi is also in power set. So yeah, phi is also in power set. So phi will correspond to an empty relation. Like an empty relation is also a relation. Like you can just assume it's a null relation. Like it's just something which and a relation is a basically object. It's an object which contains nothing. So I don't think that matters that much. But yeah. So I'm till now we are just finding the till now this 2 to the power 16 basically corresponds to all possible relations, all the number of possible relations. So someone asked, then you can say 2 to the power 16. But in this question, we have to find the number of reflexive relations. So note that in the all possible relations, what we did was basically every element, there are 16 elements in S cross S, and every element had a choice whether to be included in the set or to be excluded from the set. Right, guys? But to find, I just type it up here. But to, but for a relation to be a reflexive relation, all the some elements are there which must be in the, like basically a comma a should be in R for all a, for all possible a, for all a in S. So basically for all elements of S, the for all elements a of S, the a comma a should be part of the relation. Otherwise, the relation won't be a reflexive relation. And if this condition holds true, then it is a reflexive relation. So basically, this what this means is that, guys, the relation R should contain 5 comma 5. 5 comma 5 should be there. 7 comma 7 should be there. I'm just from where are these numbers 5, 7 coming from? These are just the numbers of set S. So similarly, 13 comma 13 should be there. And 15 comma 15 should be there. Right. So these I'll just highlight this much. So basically the relation R must contain these 4 elements. And after these 4 elements are there, then all other elements after including the above 4 elements in R, the relation is guaranteed. You can see this easily, that the relation is guaranteed to be reflexive, right? Because now I have fulfilled this condition that all of a comma a should be in part of the relation. So the relation contains 5, 5, 7, 7, 10, 10, 15, 15. So it is guaranteed to be reflexive. So I can add any more elements to this set, or I can leave them also. So basically, besides these 4 elements, there are like 12 elements more remaining. There were total 16 elements here. So out of the 16 elements, my set must contain these 4. And for the remaining 12 elements, I have a choice whether to include them or not. Right, guys? So I have a choice whether to include or exclude any of the remaining 12 elements. Right, guys? So this corresponds to, which corresponds to 2 to the power 12. Basically 2 to the power 12 possible choices. Basically for every remaining 12 elements, basically I have got these 4 elements. There were total 16 elements. So the difference between 16 and 4 is 12. So basically for these 12 elements, I have basically a choice over every element, whether I can include it in my relation or I can exclude it in my relation. So 2 choices for every element, and like basic counting argument, since there are 12 elements. So there will be 2 to the power 12 choices. Basically there will be 2 to the power 12 choices for the relation R. Basically there will be 2 to the power 12 choices for, yeah, for let's say for creating a subset which includes the above 4 elements. The this write it rewrite it. So basically the above 4 elements, the relation I'm referring to these four elements, 5, 5, 7, 7, and so on. So basically I have to do the by 12 choice for creating a subset which includes these 4 elements. So I guess this is clear. So basically this corresponds to the number of ways I can define the relation. So 2 to the, this will correspond to like 2 to the power 12 choices for describing the relation R. Or maybe just I write it as for the relation R. So basically from this we see that 2 to the power 12 choices for the relation R. So which comes out to 4096, which is the correct answer. So yeah, the 4096 is the answer. I'll just this, yeah. So this is the basic answer. So yes, Aditya, you had written to the part 12, which was correct. So Sola, you had earlier written an answer of 4. So is it clear to you now why is 4 the incorrect answer and this is the correct answer? Basically, a relation is described by the whole set, the whole subset which it includes. So there are 2 to the power 12 choices for describing this subset. Okay, cool. So you understand this. Nice. So just to add on to this question also, guys, uh, suppose instead of the total number of reflexive relations, what if I ask, what if we need to find total number of, let's say, symmetric relations of, let's say, this set only. Yeah. So would anyone like to give it a try? It is in the same spirit as uh, the approach discussed here. Okay. So Aditya is writing in the chat 2 to the power 10. So maybe we'll just, okay, we can maybe, should we discuss this or should I leave it for you guys to figure it out yourselves? Maybe I'll just, if we have time, like I'll just move on to the next problem. If we have time, we'll come back to discussing this question, like if finding the number of symmetric relations to this. I'll just leave the correct answer here. So what would be the correct answer? Take 1 second. So yeah, so correct answer, just let me think of it. So there would be 16 entries. So 4, 7, 9, 10. So yes, Aditya, you are correct. So the answer here would be basically 2 to the power 10. So here the answer would be 2 to the power 10. So I'll just, as per now, I'll just leave it to you guys to try to do it yourself as a self exercise. Yourself. Okay. And if we have time in this session remaining, we'll just come back to this. But the correct answer is 2 to the power 10. Similar arguments would apply as we had applied here, that these sort the relation R must contain, at least here, since it was like reflexive, it should contain 5, 5, 7, 7, 13, 13, and 15, 15. So here what we'll say is that the relation R, basically, if I choose something like, let's say, AI comma AJ, then AJ comma AI should also be included. So similar sort of arguments will can be applied here to find this answers 2 to the power 10. So I'll just leave it to you guys as for now. Yeah. So yeah, Tehseen 1024. Yes, that's the correct answer. 2 to the power 10, as I have already written. It computes 1024. So I'll not discuss this right now. So let's just move on to the next question. So let's just find out. Let's just see the question 4. So question 4 is basically saying, let us set S be like the set 1, 2, 3, 4, 5. A relation on R is defined as R is B comma A, such that uh, 0 is less than equal to minus A plus B. This is B minus A, right? So maybe we just write it as B minus A. So it is a little clearer in the notation. So a relation on set is defined as R is B comma A, such that B minus A lies between the range 0 comma 3. So basically, what is the cardinality of set R? So basically, the relation R says that we need to find basically like B comma A takes values from these, like the set 1, 2, 3, 4, 5, and we define the set R such that the difference of these elements should lie between 0 and 3. So we need to find the number of possible pairs like B comma A such that we need to find the basically cardinality of set R. So basically this corresponds to we need to find the number of elements B comma A such that B minus A lies between 0 and 3, and B and A both are from this set S. Right, guys? So I hope this is clear to you what the question is asking for. So I'll just write it down. We basically need to find B comma A number of possible B comma A such that B and A both belong to S, and like B minus A lies between 0 and 3. So just to see like how can we do it in a like you can just try out like there are like 5 values in set S. So the naive approach, or let's say the brute force approach. Brute force approach would be there are since size of set is 5, the size of set S is 5. So this implies that size of the set S cross S, as we had discussed earlier, would be 5 square, which is 25. So basically, try all these 25 possible values for the pair P comma A. So basically, this brute force approach, just to give you guys an idea what I'm writing, basically in this brute force approach, what we can do is basically take the all possible pairs of B comma A, and then check how many of these satisfy this condition of b minus a is less than, greater than equal to 0 and less than equal to 3. Try all 25 pairs for b comma a and check how many of them satisfy this condition. Basically, I'll just copy it from here. Yeah. So this is a straightforward brute force approach, and this will take, like, you have to check for 25 possible pairs. So maybe we can try to do a bit faster approach. Basically, it will do the same thing, but we can just try to do it in a smarter way. So smarter approach, I feel, would be that we can make, like, let's say, make cases for possible values of a. So right. So basically A will take since A and B both are taking the values from 1, 2, 3, 4, 5. So A will have values, basically A will either be 1, A will 2 or 3 or 4 or 5. So basically we'll take all the possible cases and add up all those values. Basically when A is 1, what are the possible values of B? Plus the number of possible values of B when A is 2, plus number of possible values of B when A is 3, and similarly for when A is 4 and 5. So let's just make this a list, I would say. So yeah, A is 1, let's say. So in this case, so basically we need to find the possible B such that 0 is less than equals to B minus 1 is less than equals to 3. So this will basically mean that B should be between, uh, I hope I'm making sense, guys. So Aditya and Solat, Aditya, you have written the answer to this question as 14 and Solat as 16. So yeah, we have two conflicting answers. Let's just do this approach and find out what the correct answer is. So you guys can also figure out, like, who was incorrect and why was your approach maybe incorrect. So yeah. So just taking the cases. So first case is when A is 1, and in this case 0 will lie. But basically I have put in this condition the A as 1. So basically B minus 1 will lie between 0 and 3. So B will lie between 0 and 4. So since B can take the values between 0 and 4 as 1, 2, 3, 4. So 4 possible values for B. So here the possible values are like 4 in this case. So in case 2, A is equals to 2. In this case, similarly, we'll make the same claims. I'll just copy these, but edit these along the way. So here, what will happen is when A is 2, we'll have the constraint that 0 is greater than equal to B minus 2 is 0 is less than equal to B minus 2 is less than equal to 3. So this will come out to like B lies between 2 and 5. So between 2 and 5, we can take the values from set as 2, 3, 4, and 5. So again, we'll have 4 possible values for B, basically 2, 3, 4, 5. I hope it is clear to you guys. Maybe these less than equal to and these are maybe confusing you. I'll just to avoid some confusion, I'll just switch these implication signs and these less than equal to operators so that it becomes a bit more clear to you guys what's happening. Basically, I'm just doing some notational changes to avoid confusion to everyone who's reading this. I think so. Yeah. So I basically have written everything same as before. So similarly, we'll arrive at case 3, which is when A is equals to 3. So in this case, again, we'll write the step that 0 is less than equal to B minus 3 is less than equal to 3. So B lies between, like, let's say 3 and 6. But even though B lies between 3 and 6, the number of possible B's in this range are only, let's say 3, 4, and 5. Since S does not contain the element 6, so we can't take the value 6. So we can only take the values as like 3, 4, and 5. I think I'm making sense, right, guys? Yeah. So here we can only take three values, basically which are 3, 4, and 5 out of set S. So yeah. Similarly, let's come to the case when A is 4. So when A is 4, we will take the values between 4 and 7. Again, between 4 and 7, we can only take 4 and 5 because we can only take the values from set S, and set S has only 1, 2, 3, 4, 5. It will take two possible values. And similarly, when A is 5, again, we do the same step, and here we'll arrive at B will lie between 5 and 8. So here only like from between 5 and 8 only we can take the value 5. So only one possible value. So since A can take only these 5 values, 1, 2, 3, 4, 5. So we have covered all possible cases for the values of A and found out which values of B are possible. So here, like basically here you needed to do in this brute force approach, you will need to try out all these 25 possible values. Here we have just made these 5 cases of values of A and just directly said how many values will B can take using this. So the total possible values of B would be total possible values for AB will be total possible values for A comma B is equals to the sum for all these cases, which is 4 plus 4 plus 3 plus 2 plus 1. I hope this counting argument is clear, guys. Why we are taking the sum of all these values and not product or something, because we have just divided the possible values for in all these cases, all these disjoint cases. So when finding out the total possible answer, we'll just have to take the sum of all these disjoint cases, right? So this will come out to 4 plus 3 plus 2 plus 1 comes out to 10, and then adding 4, which is equals to 14. So 14 is the correct answer. I hope I'm making sense, guys. So yeah, Aditya and Hetal, you had written 14, which was correct. So Solat, you wrote 16. Maybe you can review later why your answer was incorrect. Okay. So Tahseen is asking, please elaborate B and A value. Who's considered A and B? Okay, it should be B comma A and not A comma B. Okay, I guess you guys have been confused notationally a bit. So yeah, the pair is ordered as B comma A, not as A comma B, which has been correctly pointed out by Aditya. So yeah. So basically we are just taking the cases for all possible values of A, and then we are trying out like what values B can take so that we can make a pair B comma A. So basically this is B comma A here. So total possible values for the pair B comma A will be like basically B can take let's say A will take 1, and then B can take one of these 4 values. Similarly, when A is 2, B will take like one of these 4 values. When A is 3, B will take like, let's say, 3 of these possible values. So maybe I'll just, okay, so there is some confusion, I guess. What is this B comma A pair? So maybe I'll try to list out all of these values also. So, okay, listing out all these possible B comma A. Okay, so just to see like, so that some people can some people have doubt in what are these B comma A values. So the set S of all these possible B comma A values will be, suppose let's take the case when A is 1. So we will be taking the value 1, 2, 3, and 4. So the possible pairs here would be basically B is 1, similar, and A is 1. Then B is 2, but A is still 1. We are still considering the case of A is 1 only. Here we'll have like 4 values for B. Similarly, 3 comma 1, and similarly 4 comma 1. So now the case of A is equals to 1 is done. Now we'll arrive at the case A is 2. Maybe let me just copy this, guys. So okay, never mind. I'll just write it down. So these are the 4 possible cases. 4 cases of B comma A when A is 1. So now I'll type out again for when A is 2. So when A is 2, B can take the values as we have found out from 2 to 5. So B will take 2, where A is already 2. B can take 3 and A is 2 as we have defined. Similarly, B can take the value 4, A is 2, and B can take the value 5 and A is 2. So these will be the 4 cases of A comma B when A is 2. And similarly, I'll just copy this now. I hope it's clear to you. So now we are taking the case of A is 3. Here there are 3 cases. What these 3 cases correspond to is that, again, like let's just change the entries. So when A was 3, B can take the values from 3 to 6. So B will take, like, let's say 3, and B can take the value 4, and B can take the value 5, and A was 3 as we know. So yes, but B can't take the value 6 as 6 is not in the set S. So now I hope it's clear now. Similarly, I'll be just be writing it down. I write down faster for when A is 2. So when A is 2, there are 2 possible cases. Basically, okay, sorry, A is 4. This is the case when A is 4, and there will be like 2 cases. And 2 cases are when A was 4, when A was 4, B can take the values like between 4 to 7, and since it belongs to set S, so it can only take values 4 and 5. So these will be like 4 and 5. So B comma A pair will take 4 comma 4 and 5 comma 5. Similarly, when A is 5, only one case. We'll arrive at only one case as we have already mentioned, which will be A would be 5 and B would be taking the value. B lies between 5 and 8. So only 5 belongs to set S. So it will take the values 5. So these are all the possible. So these values which I have written down, the underlying values. Let me just underline. So these underlying values are the possible pairs of values which B comma A can take. So as we can see, like there are 4 plus 4 plus 3 plus 2 plus 1, which is 14, as we have already counted. So these are the 14 possible B comma A pairs uh, which satisfy these conditions. So I hope I'm a bit more clear now. So Tessie, does this make sense now? You can let me know by typing in chat or by a thumbs up if what I have written is clear to you now. Okay, cool. It's clear to you. Okay. So moving on to the next question, guys. So okay. So the fifth question is basically saying that let R be a relation on a collection of set defined as follows. So basically we are defining here the relation R is defined over sets. Generally here, let's say in the fourth question, we define basically here R is defined on a collection of sets. Like here, what we define the relation of R as the pair B comma A, right? So, and we define some conditions on these values, on these like numbers B and A. But here basically it's saying that the relation is over sets instead of like a pair of sets basically. Here B and A were numbers and we had some conditions over B and A. But here we are defining over sets. Basically earlier small a and small b were numbers, and here we are defining the relations over sets. So these are not numbers, these are sets. This is capital A and capital B. So basically, A and B are related if like A comma B is a part of the relation uh, when A is a subset of B. So this is a subset. This is a notation for a subset, as we already know. You guys must already know. So basically, relation R says that A comma B belongs to R. Basically, A comma B are related if and only if A is a subset of B. I hope it is clear, guys, what I'm trying to say. I'm just saying that here these capital and capital B are sets. Here these small b and small a were numbers. But similarly, we can define relations over sets also. This can be anything basically. So, yeah. So relation R says that A comma B belongs to R if and only B is a subset of B. So now we need to find which of the following options is our correct. Right. So let's just do it option by option. So option A says that R is reflexive and transitive. So do you guys think it's correct? Maybe I'll just start solving it maybe. So reflexive means that, what does reflexive mean? Reflexive means that any element A comma A should, for checking if the relation is reflexive, should be in R, right? So this implies that A, okay, I'll just copy this subset symbol, should be a subset of A. To check, okay, I'll just write down this. So let's say, suppose like A is a set. This, let's not confuse this with option A. Here A is a set, so this A comma A pair should be in R, which implies that A should be a subset of A, which is true. Or maybe I just write it in opposite sense. Okay, so let's just say since we need to check for reflexive, basically we need to check the element A comma A, whether A comma A is in R. And for checking A comma A should be in R. And it is true since A is a subset of A. Basically, a set is a subset of itself, right, guys? So again, I'm going a bit back and forth, but I guess this sometimes happens. So yeah. So for reflexive, for R to be reflexive, A comma A should be in R. A comma A, this pair should be in the relation R. And this is true since A is a subset of A. So yeah, this means that R is reflexive. Is it clear to you guys? You guys can raise a question in chat if you have any doubts or this does not make sense to you. Basically, here the definition of relation has been changed to over being sets rather than numbers. So you guys might face a little bit. You might guys think it's a bit tricky, but it's just the same thing applied to sets. So yeah. So for R to be reflexive, basically we need the element A comma A should be in R, and it is true since A is a subset of A, so it will belong to R. So now for we also need to check for transitivity. So similarly, I'll just write it down for R to be transitive. For R to be intransitive, A comma B in R. I'll just write down the definition of transitive, and B comma C in R should imply that A comma C in R. So for checking whether relation is transitive, so we just need to check whether like A comma B should be, if A and A comma B is in R and B comma C is in R, then A comma C is also in R. So basically this middleman B can be eliminated and these A and C should also be part of the set R. So is this relation transitive? So let's just check. So let's just take number, like let's just take two sets A comma B in R. And this implies that A is a, sorry for this. Yeah, and this implies that A is a subset of B. And similarly, B comma C in R implies that B is a subset of C. Right, guys? So basically, we need to check for these conditions that these two conditions should, if these two conditions hold, then this should hold. So for checking this, I'm just saying what happens when these two conditions hold. So when A comma B is in R, this implies that A is a subset of B, as we have defined in this relation that if the set a pair A comma B is in the relation only if A is a subset of B. And similarly, B comma C in R holds, then B is a subset of C. So from these two statements, we can say that like A is a subset of B and which is a subset of C, right? And this implies that since like A is a subset of B and B is a subset of C, so this you can easily see, as we have already done studies it, that this implies that A is a subset of C. Right, guys? I don't think this part is too difficult to follow. So this, and if A is a subset of C, and we have seen that if A is a subset of B, then A comma B is in the relation R. So if A is a subset of C, this implies that A comma C is in R. So, so basically we took these two conditions that A comma B is in R and B comma C is in R, and we have shown that A comma C is in R. So this, by this we have shown that R is transitive. So I'll just underline the properties of R. You guys can see the mid properties here. So yeah, Aditya, you are saying that option A is correct. So yeah, as you have correctly written that option A is correct. But since there can be like maybe multiple options correct, so we'll just check for all the options one by one. So for option A says that R is reflexive and transitive. So yeah, R is reflexive as well as transitive, as we have already shown. So option A is correct, but we'll just check out all the other options also and just write it down. So option A is correct. So for option B, maybe I'll just move this question to, okay, maybe not. For option B is asking if R is symmetric. So here for R to be symmetric, A comma B in R, if and only if B comma A in R. So for a relation to be I'm just writing out the definition of symmetric relations. So for R to be symmetric, A comma B in R, a pair A comma B in R, if and only if B comma A in R. And generally for symmetric, basically for symmetric, you guys can also assume that B is also not equals to A. This is not equals to symbol. This exclamation equals to. Maybe I'll just write down here. Okay. For all B, just writing out the definition of symmetry. For all B not equals to A, for all elements B which are not equal to A comma B is in R if and only if B comma A is in R. This is the basic definition of symmetric. So because this is like why have we taken this B is not equal to A case? Because like suppose B equals to A, in that case B can be replaced by A. So it just means A comma A in R if and only if A comma A in R. So that statement is trivially true. So we don't consider that statement, but we only consider for all B which are not in A, right? So I hope I'm making sense, guys. So this should hold. So let's just check if whether this holds or not. So let's just say A comma B is in R. So A comma B is in R. When what does this mean? A comma B in R, and also B is not in A. B is not equal to A. I'll just get back to it later. So B A comma B in R implies that A is a subset of B, and since and since B is not equals to A, then this means that A is a proper subset of B, right, guys? And since B is not equal to A, then we can just say that, or maybe I can write it in a better form. Okay, maybe what we can do is we can do something like contradiction. Let's say for I just written this definition for R being symmetric, like for all B not equals to A comma B in R is if and only B comma A in R. This is basic definition. So let's assume that R is symmetric. Like I don't know whether it is symmetric or not, but let's just assume it is symmetric. Then what does this mean? This means that uh, A comma B. This means that A comma B in R if and only B comma A in R, right, guys? So what does this imply? This implies that A comma B in R. This implies that uh, A is a subset of B, and similarly B comma A in R. So let's say basically A comma B is in R. This statement is true. Then what does this imply? From our assumption, this implies that B comma A is also in R, and that like A comma B is in R, then A is a subset of B. And since A comma B in R, since we have assumed the relation to be symmetric, so B comma A is also in R. So B comma A is also uh, in R, and this implies that B is a subset of A. So I just basically written down the definition of these two conditions, like A comma B in R means that A implies B, and B comma A in R means that B is a subset of A. Right, guys? It is nothing too fancy. So basically, if R is symmetric, then this means that if A is a subset of B, so what we can say is that so if R is symmetric, let's say R is symmetric. We have assumed that R is symmetric, then A is a subset of B, and this will mean that A comma B is in R. And this will mean that B comma A is in R because R is symmetric. So this will imply that B is a subset of A. So A comma B is A subset of B will imply B is a subset of A. And what does this tell us? If A is a subset of B and B is a subset of A, this will imply that A equals to B. I hope it's clear. Like in sets, if one set is the subset of another and the other is the subset of the first, then both the sets are equal. Like this we have studied in set theory and it's quite obvious. So what does this mean? A equals to B. But originally we had assumed that B is not equals to A, right? But we had assumed that B is not equals to A in definition of symmetric relations. So basically, uh, we had assumed that B was not equals to A, but we have proved that if R is symmetric, then B equals to A. Hence, we arrive at the contradiction. I hope you guys can see what the contradiction is. So basically, the basic step what we have taken is we have assumed that let's take some B which is not equal to A, and let's assume that R is symmetric. So if R was symmetric, then let's say some A comma B was in R, then this would mean that B comma A is also in R. So if A comma B is in R, this means that A is a subset of B. and B comma A is in R, this means that B is a subset of A. Since these two conditions hold, this means that A equals to B. But we had initially assumed that B is not equal to A. Here we have arrived at A equals to B. So basically we arrived at a contradiction. Hence, R is not symmetric. Okay, so Tehsi, you have B, you have written what does B exclamation mean? So if you have followed my previous lectures, so generally I represent not as this. So basically, let's just type this out. Maybe I'll type this out in notation here. Notation. Oh, sorry. Yeah, so the notation I use is B not equals to A means that not equal. I hope it's clear now. Okay. Yeah, use for negation sort of. Yeah, that's it. Nice. So yeah, so R is not symmetric. So option B says that R is symmetric. So option B is incorrect. So option B is incorrect. So now let's arrive at option C. Option C is basically R is antisymmetric. So using similar arguments, I'll just go through these arguments fast. There are these arguments are similar and asymmetric. For R to be antisymmetric, uh, so let's say antisymmetricity is basically defined as for all B not equals to A, if A comma B is in R, then B comma A not in R. So basically symmetricity was defined as if A comma B is in R, then B comma A is in R. But antisymmetry is defined as if A comma B is in R, then B comma A is not in R, for all B not equals to A. So is R antisymmetric? I think you guys can see it yourself, like the proof will be similar to option B, or proof or the steps involved would be similar to option B and A as we have already done. But let me just show you. So basically R will be antisymmetric as we'll see. So why is it antisymmetric? So let's just check, like let's say for all B not equal to A comma B in R. So uh, so let's just assume this A comma B in R. So this means that this implies that A is a basically we'll start from this side and we'll show that this side holds. So basically we'll start from this for all B not equal to A is A comma B is in R, and then we can show that B comma A is not in R. So how will we go about this? So let's just check what is given to us. So A comma B is in R. So this means that A is a subset of B. So and we also know that also B is not equals to A. Right. So guys, so this basically means that what this means is that B is A is a proper subset of B. Right? This proper word is important. In proper, what does proper subset mean? Basically, uh, basically it is a proper subset means that there is at least one element in B which is not in A. Implies at least one element in B which is not in A. So what does this mean? This straightforward means that B is not a subset of A, right? At least one element in B. Since there is one element in B which is not in A, so B can't be a subset of A, because let's say that element, let's name that element X. Let's name that element X, which is in B, but it is not in A. So B is not a subset of A, as X is a part of B, but not A. I hope it's clear to you guys. Okay, so yeah. So these problem solving groups, Tehseen, you guys can figure out these logistics yourselves. I guess these would be on the instructions would be on NPTEL. Let's just focus on like the problems and their solutions for now. Okay, so right. So basically what we are seeing here is that if A comma B was in R, this means that A is a subset of B, and also B is not equals to A. So this implies that A is a proper subset of B, which means that at least one element X in B which is not in A. So B is not a subset of A, as X is a part of B, but not A. So, so what does this imply? This implies that B comma A uh, is not in R. I hope you guys can see why, because for B comma A to be in R, B should be a subset of A. But since we have shown that B is not a subset of A, so B comma A is not in R. So this will mean that uh, hence R is actually antisymmetric. Okay. I hope this is clear to you guys. So option C is correct. Option C was saying that R is antisymmetric, and we have shown that actually R is antisymmetric. As if A comma B is in R and B is not equal to A, then B comma A is not in R, as we have seen. So option C is correct. So similarly for option D, we have already shown that R is reflexive, but not transitive. But we have actually shown that R is transitive in option A. So option D is incorrect. So option C is correct. Option D incorrect, as R is transitive. Already proved above. Right, guys. So the correct answer is, as we have already seen. So correct answer is option C was correct. Option B was incorrect. Option A was correct. So A comma C. So I guess this makes sense, guys. So yeah, Aditya and Hetal, you have written, like Aditya had written option A and Hetal had written C also. So you guys collectively are correct that A comma C was the correct answer. Good job, guys. So let's come to question 6 now. So question 6 says that let a relation R be defined as R is A comma B such that both A and B live in the same city. So basically R is a relation which says that two people, let's say A and B, are related if and only they both live in the same city. So I guess like it's similar to the previous question. So similar in flavor at least. So we can try to do this orally so that we are faster. So all of these things, I have written these down properly, but once you have enough experience or let's say enough practice, you guys can do these sort of questions orally also. Like there's no need to write everything down and solve properly. You guys can just do it in your minds and be done with it as fast as possible. Yeah. But so yeah, we'll try to do it a bit faster here. Sixth question. So let a relation R be defined. So basically A and B are related if they both live in the same city. So we have to pick out the correct statement. So R is antisymmetric. So let's see if right. So is R antisymmetric? So what is antisymmetric? If A comma B is in R, then B comma A should not be in R. But here, if A comma B is in R, this means that A and B live in the same city. So as A and B are living in the same city, this would mean that B and A also live in the same city. Like, let's say me and you live in the same city. This also means that you and me live in the same city, right? The ordering does not matter. So basically, mm, if A comma B is in R, then B comma A would be in R. So R is not antisymmetric. So option A is incorrect, as if A comma B in R, A comma B live in same city, then okay, we get this right. As if A and B live in the same city, then B and A also live in same city. Okay, guys. So option B. Okay, Aditya is saying option A, C, D, and Heather is saying option B, C, D. Let's just see what the correct answer will arrive at. So Aditya, your answer is definitely incorrect, as option A we have already seen is incorrect. So yeah, I think it's clear like Y's are antisymmetric, right? Because if A and B live in the same city, B and also live in the same city. So it can be antisymmetric. And option B, the R is reflexive. So reflexive is A comma A should be a part of the relation. So this will mean that A comma would be part if both A and A live in the same city. So yeah, so the single person A will be living in only one city, right? So both A and A live in the same city is correct statement. So like, so basically R would be reflexive, as A comma A would belong to the relation R, right? Correct. As A and A live in the same city. And this is trivial. Like if there is one person, he or she will be living in only one city at a time. So yeah. So option C is our transitive. So transitive means that, let's try to do this again only. So if A comma B, A and B live in the same city and B and C live in the same city. So let's name the city like let's say Delhi only. So A and B are living in Delhi and B and C are living in Delhi. So this means that A and C both are also living in Delhi, right? So basically A and C are also living in the same city. So then A comma C should also be part of this relation R, right? So this would be correct, as all, as if A comma B, as if A and B live in same city and B, C live in same city, then A, C live in same city. I guess you guys can see this. See, that's just a grammatical things. So yeah. So and option D is R is symmetric. So yeah, if A and B live in the same city, then B and A also live in the same city, right? Option A said they are antisymmetric, but we established in the option A that if A and B live in the same city, then B and C also live in the same city. So actually option D is symmetric is correct. And the reason is already discussed above. So where have we discussed this? We have discussed this in option A. Option A, we have already established that if A and B live in the same city, then B and A also live in the same city. So yeah. So the correct answer is then correct options are B, C, D. Okay. So yeah. So Hetal, your answer of option B, C, D was correct. So yeah. There you can just see. I hope it's clear to you why A was incorrect. So, okay, guys. And as you can see, like, so basically we established that R is reflexive, transitive, as well as symmetric. So basically R is basically if a relation is reflexive, transitive, and symmetric, then it is also equivalent, right? So hence you can just establish like as a side note, hence R is an equivalence relation. Just a side note, guys. Okay, Hital, I think you have a question and I'll just read it out. I was having one query. I do not have meeting recording accessible as I have registered to this course with Gmail account, but I joined meeting using other team's account. Can you help me in this regard? So I don't know if I can help you with this, Hazel. I guess you'll have to contact the hello. Am I audible, guys? My internet connection went away for a bit. So, okay, nice. I'm audible. So yeah, Hital, as I was answering, so basically, whatever these meeting recordings are, we upload these recordings to YouTube. So I don't think you guys need any account access or anything for accessing YouTube, right? So the YouTube link would be provided to you by the NPTEL team, or you'll have to contact like the logistics team to get so that you guys can get the link. But these recordings are available on YouTube, so you don't have to worry that you won't be able to access these recordings or anything. Just reach out to someone at NPTEL or like so. No, any email IDs are not required, Hital. As I'm saying, these YouTube links are public. I guess they'll be posted by the NPTEL staff when they have to. So I'm not sure when will they post the link of these videos to you guys, but they'll become available to you. So you don't have to worry about this. It doesn't matter whether you use Gmail account or Teams account or anything. You just need to be registered on the NPTEL portal for the course. That's all. So again, I would like to move these move these queries related to logistics offline. Maybe you guys can post these on discussion forums or something. And I prefer that we stick to like problem solving since we only get 2 hours in a week. So maybe you can just, Hetan, maybe you can just put out your queries at the discussion forum, NPTEL discussion forum or somewhere, so you can get better answers related to these queries. I'm just the problem solving TA, so I don't know I'm not the one you should be contacting for logistics related stuff, I would say. Those guys can answer your queries better, basically. So yeah. I don't think it will be too much of it will be too much of a worry for you. Like it's these recordings will be available. Like you don't have to worry whether you have to use one account or which ID or anything. Uh, Basically, what I'm saying is you don't have to worry. Like you will be able to access the recordings at some point. Like they'll be available on YouTube, so no issues there. So yeah, so let's just move on to uh, the seventh question. So seventh question is again asking which of the following is an equivalence relation. So for equivalence, so just to reiterate, guys, for a relation to be equivalence, it should be symmetric, transitive, as well as reflexive. Uh, Again, Hital, so maybe you can ask this on discussion forum. You can ask this on the NPTEL discussion forum, and I think you will be able to get the answer to this. or maybe after the meeting ends, I'll post the link. I'll directly post the link to the YouTube videos on the meeting chat only after this meeting ends, so that you guys can just click on that link and view the videos directly. So let's just move away from these recording discussion. I'll just post the link afterwards. So yeah. So so for the seven question is basically asking which of the following is an equivalence relation. So basically we are given a bunch of relations, the four options, and for relation to be equivalence relation, it should be symmetric, transitive, as well as reflexive. We guys have studied this in lectures. So again, I'll just leave it since there's a bit of shortage of time. I say that I'll leave these guys to you as exercise. Try it yourself. Okay, so I'll just give out to you the correct answer. So I can maybe if you guys can follow, I don't know the correct answer. I'll just be solving it here only. Correct answer is, so first relation is A, comma B, both A and B are even non-zero integers and A by B is an integer. So here we can see, like, let's suppose this relation is, I'll just say my thoughts loud. So if you guys can follow, then that's good. Maybe you guys will understand like how we can do these sort of things faster, and you guys can understand how am I arriving at these answers. But if you guys don't follow, just try to do it yourselves using pen and paper and stuff. So you guys understand why this answer is correct or this answer is wrong. So A and B both are even non-zero integers and A by B is an integer. So suppose, so let's check for symmetricity first. So this relation R is this R is reflexive, as suppose A comma A. Suppose an element is A comma A, so A by A will be equals to 1, which is an integer. So it will be reflexive. But for transitivity, we require A by B to be an integer as well as B by A to be an integer. But let's just suppose A is 4 and B is 2. So 4 by 2 is an integer, but 2 by 4 is not an integer. So this relation is not symmetric. So basically option A is not maybe I'll just type it out here so you guys can hints. I just put something there. Option A is not symmetric, and let's put this question on the next page itself. Yeah, option A is not symmetric, and option B option B is x comma y, y minus x is 0. So this basically means that y is equal to x. So if it is reflexive as x equals to x trivially, it is symmetric that if y is equals to x, then x equals to y. Similarly, it is transitive as well, as if y is equal to x, and like if x equals to y and y equals to z, then x is also equals to z. So it is equivalence relation. Equivalence. So option C is basically it contains set 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, and 5 comma 6. So as we can see trivially that it is like if 1 comma 2 is there, but no 1 comma 1 is not there. Like for the relation to be reflexive, it should contain like the elements of the form A comma A also, but 1 comma 1 is not here. So not reflexive. So this won't be. So similarly, option D. Option D is A comma B, A is less than equals to B cube. So A is less than equals to, so let's suppose it is, let's check for reflexivity. So here for reflexivity, A comma A, such that A is less than equals to A cube. So basically this won't be let me just think about it a bit, guys. So yeah, so A comma A won't be a reflexive relation as well, right? Because 2 is less than equals to 2q does not hold true. So this won't be, yeah, so this won't be, I guess, a reflexive relation, or you can just see that it won't be a symmetric relation either. So let's say A is less than equals to B cube, then it is not necessary that B is less than equals to A cube. So I'll just leave it out there. So you guys can think about it later. Not reflexive, comma, symmetric, I think. Or you guys can figure it out yourself. So the correct answer would be, yeah, correct answer would be like option B. And you guys can try it out yourself also. I'll just provide some basic hints by doing some things orally, and this is what I have arrived at. That's what I'm saying. So yeah. So let's move on to next question. So wait a second, guys. Sorry. So yeah, so this eighth question is, suppose the cardinality of set A is 4 and cardinality of set B is 3. What are the cardinalities of the Cartesian product A cross B and the power set of A into B? So we have already seen that as we had already discussed that for calculating A cross B, we had already calculated even what does this Cartesian product mean in one of the questions. If I remember, yeah, here we had calculated. So Cartesian product basically means that we need to pair up one element from each of the two sets of which we are taking the product. So basically, the cardinality of set A is 4 and cardinality of set B is 3. So what basically we mean is that we need to select, we need to pair up one element from set A with one element from set B. So we need to form a pair of the form A comma B. And since there are 4 choices from set A and 3 choices from set B, so in general, what we can say is that cardinality of Cartesian product will be, we have mod A choices for selection from set A, and similarly we have mod B choices from selection of mod B. So this will just be equals to cardinality of A is 4 and B is 3. So just putting in these values, this will give us 4 into 3, which is 12. Right, guys? So cardinality of A into B is 12. And similarly, the second question is like cardinality. We need to find out. Sorry. So, and now we need to find out cardinality of power set of A cross B. POW denotes the power set. So this will just be basically a set with n elements has a power set of size 2 to the power n. So A cross B has size 12. So it will have basically power set of 2 to the power 12 size. So I hope it's clear to you guys. It's nothing too fancy. So this is the answer. So yeah. Maybe I'll just write it out as 4096. So yeah. Okay, let's come to the ninth question. So ninth question says that which of the following collection of, so yeah, Aditya, your answer 12 comma 2 to the power 12 was correct. So for ninth question, which of the following collection of subsets is a partition of A? So guys, partition of A is basically partition of a set S is collection of disjoint. So in partition, this disjoint word is very important. Collection of disjoint subset of S such that the union of all. Okay, so collection of disjoint subset of S such that union of these collection of subsets is equals to S. So basically we break. So basically, partition, like in the name itself, basically the partition of a set is basically dividing the set into some disjoint smaller subsets, such that the union of all these smaller subsets gives us S again. So I guess you guys must have seen the definition in lectures also, and this is almost the similar definition. So the most important thing is that this should be disjoint. So the two things to look for in a partition is that all the subsets should be disjoint, as well as the union of these subsets should give us the actual set, the original set S. So here the set A is 1, 2, 3, 4, 5. So here, let's just visit option by option. So option A is the first set as 1, 2, 3, and second as 2, 3, 4, 5. So since partition should be disjoint, so this is not a partition, not a partition, as subsets are not disjoint. So similarly, going for, let's see option B. Okay, so many people are saying option D in the chat. So let's just see. Let's go option by option. So option B is like one is set 4, the other is 2, 3, 1, 5, and 2, 3. So here we see that 2, 3 and these sets 2, 3 are not disjoint. So they have common intersection. So option B is also not a partition, same reason. I'll just copy and paste, as subsets are not disjoint. Easy. Let's just move to option C now. So option C says that 1, 5, 2, 3, 4, 5. This 5 again is a common intersection of 1, 5, 2, 5. So again, the same reason. So not a partition, and these are not disjoint. So now let's come to option D. So in option D, 1, 2, 5, and 3, 4. So all of these are disjoint with each other, like basically 1, 2, 3, 4, and all of these subsets don't have any common intersection, and they make their union is basically 1, 2, 3, 4, and 5, which is basically the set A itself. So this is a valid partition. Note that there can be many partitions of a set. So basically, this is not the only partition. Like the another partition can be 1 and then 2 comma 5 and then 3 comma 4. So there can be a lot of partitions of a set. So just a fun question, like do it yourself. Try it yourself. Number of possible partitions of set A. So I'll not give a hint or anything. Maybe you guys can read about this online or something, like how to find the number of possible partitions of a set. Here the set is of small size, but suppose of a set of size n, what is the how many partitions are there in general? So yeah, you guys can read it up. It would be a fun exercise that it will revise your combinatorics as well and give you better idea about sets and relations also. So yeah. So going to the last question. So initially I had also planned to revise some of the basically primarily the islands, knights and knave problem which we discussed last time, which I felt that I should explain again, as this problem was a bit trickier than the other problems. So I thought that if we had some time left, then we will discuss this the knights and knaves problem of the previous session again. But I don't think we are left with any time, so we'll not discuss this problem. I'll just remove this. So now this is the last problem of the day, which we'll be discussing, which is related to the sets only. So let A be a set with cardinality n, B be a set with cardinality m. There are a total of 64 symmetric relations on A and 216 antisymmetric relations of B. And we need to find basically what is n times n. So basically we need to find the values of n and m. Right, guys? So basically, as we had already seen how to find the number of symmetric relations, what are the number of reflexive relations? For reflexive relations, we had already found out, and we need to find what if, and I gave you an exercise that what if we need to find the total number of symmetric relations, right, guys? We discussed number of symmetric relations as well as number of reflexive relations, right? So let's just see a general, like I'll give you guys a general formula. You guys, as we had derived for like reflexive relations, you guys can derive this formula for symmetric relations also. So number of symmetric relations uh, of A has cardinality n, as we have been given in the question. Number of symmetric relations is equals to 2 raised to the power n minus 1 by 2. Basically this expression. So number of symmetric relations, maybe I'll just see, yeah. Okay, so this is the formula for number of symmetric relations of A. It is 2 raised to the power n times n plus 1 by 2. So this whole is in the power and n plus 1 by 2 and p raised to the power 2. So this is the formula for number of symmetric relations. So to get a feel of why is this the correct formula, you guys can just see that let's just assume to see this formula, we can see the okay, I'll just give type and give out the basic idea for this formula. Uh, let's see the matrix representation of relation R. So in that setting, we can only set the values of upper diagonal part of the matrix. So we can only set the 1, 0 values for the upper diagonal part of the matrix, as since the matrix for a symmetric relation should be symmetric matrix, so its transpose should be equal to itself. So if we set the values of the upper diagonal part, then the lower diagonal part's values will be equal to the upper diagonal part itself, right? So the degree of freedom is basically we can set the values 0 and 1 along the diagonal and the values above the diagonal only. So since there are basically uh, n plus 1, like you can easily calculate that the number of possible values, the number of cells whose values we can change are n plus 1 by 2, and we have two choices for each cell. It will be either 0 or 1. So it will come out to 2 to the power n plus 1 by 2. So this implies that 2 to the power n plus 1 by 2 as given to us is equals to number of symmetric relations is equals to 64. So this implies that 64 is just 2 to the power 6. So n plus 1 by 2 is equals to 6, which gives us n as 3. Or yeah, 3. So n is 3. And similarly, for finding the number of antisymmetric relations. Okay, Solat, you're asking some question. Okay, 1 second, guys. Solat is asking some questions in the chat. So set S has n elements in any relation that is created on S cross S. Each element is related to itself except the kth and k plus 1 elements. Which of the following relations are reflexive in nature? So maybe you can post this question in the discussion forum and TS can help you solve that question there, because I believe I should finish up since we are almost out of time. So we should be finishing this session's problems and then close out this session, since everyone will have to go somewhere now. So maybe you can post this question offline in the discussion forum and people can TS can take up this question on offline, or maybe we can take this question in the next session at the start of the next problem solving session, basically on next Tuesday. So I think we can, I'll be skipping this here, the question which you asked in chat as for now. So you can post this on the discussion forum as a doubt, or maybe we can discuss this in the next session. Okay. So let's continue with this question 10. So we had this. So basically, we had found out the value of n using the formula for number of symmetric relations on A. And similarly, I believe we have you guys must have seen in lectures, or I don't know, you guys can find out number of the formula for number of antisymmetric relations. So number of antisymmetric relations of B. So here the cardinality of B is M. So the number of antisymmetric relations is given by the formula uh, 2 raised to the power M times into 3 raised to the power uh, M minus 1 by 2, or something along these lines, guys. Let me just quickly verify the formula for this in a second. So the number of antisymmetric relations will be, just a second, guys. So yeah, I was correct. These are the antisymmetric relations. So I was just cross-checking this. So yeah, so these are given by the number of antisymmetric relations. So this is given to us as 216 in the question. So from this, you can see that we'll get, you can just solve this equation that you just put this equals to 216 and we'll get that M comes out as 3. So finding out the value of n into M is just, okay. So n into M is just 3 times 3, which is just 9. So yeah, not too difficult to show, but yeah. So I guess this is the end. This is the last problem which we have solved for today, guys. So yeah, so I have given you guys some questions which you should try out yourselves, like number of possible partitions of set A, and some more problems which you should try yourselves, and this will help your understanding a lot. So yeah, Hital, I'll be sharing the YouTube link after I end this meeting. So you don't have to worry about this. So basically, I guess we have discussed all these 10 questions, and I hope you guys have understood the concepts of sets better and how to count the number of sets and stuff like sets and relations. So yeah, hopefully this session helped you guys in your understanding. And so we'll be meeting again next Tuesday. So I'll hope to see you guys there. So as for now, thanks for coming, guys, and bye bye. Good night. You guys can leave the meeting, and I'll stop the recording.